All right, so as we're looking at multiplying power, we're still talking about exponents. So before we jump in, answer the following question. What does 3 squared really mean? It means 3 times 3. Okay. And if I say 3 squared, what does 3 to the 4th really mean? That really means 3 times 3 times 3 times 3. Correct? And if I'm multiplying those two together, how many 3's do I have multiplied together? We all agree it's 6? Okay? So could I write that as 3 to the 6th? Would that be a shortcut? Now, you have your calculator. Take your calculator and take 3 and raise it to the power of 6. Off the cuff, do you think that's a big number? Yeah, really big. How big do we have? 729. It's a whole lot easier when we're doing exponents and stuff if we can get some shortcuts. Okay, let's look at another one. Slide it down. 2 to the 5th means what? 2 times 2 times 2 times 2 times 2. All right? Times 2 to the 10th means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many total 2's do I have? 15. So can I write this as a shortcut? 2 to the what? 15. Let's take a guess, see what that is. 2 raised to the 15. I get 32,768. Did you get that on your calculator? On your calculator? I'm doing 2, hitting the button 2, and then I see this button right here, this raised to the power of, this little, like, looks like a house. Right here. I think yours is above the divided sign. And then put in 15 and then hit equals, or enter. Did you get it? Good. All right, so what's the shortcut? Instead of counting all these up, what can we do? Add them. You can add the exponents so long as one thing is true. What do you think has to be true? The base number must be the same. Abby, were you going to say the same thing? All right, so let's slide over, let's look at our notes, and let's see if what our setup makes sense. When you have a problem of product of powers with the same base, notice it's underlined, it's bolded. Do you think I want to emphasize that? Yes. You can add the exponents together. Notice the bases are the same, so you can add the exponents. So let's do this. This is a really straightforward lesson. Example 1a. Write each example using the base only once. 7 to the negative 13, 7 to the positive 5. Are the bases the same? So what we're really going to say is, what is negative 13 plus 5? Negative 8. So, since both bases are the same, we can, what would I fill in there? Add the exponents. They say when you hear something, you remember about 3 to 5%. When you write it down, it increases by 3 to 4% more. That's why I'm physically having you write the word add. Because by writing it in there, hopefully maybe it will impregnate into your mind a little bit more. All right, next one. Do they all have the same base? So here we go. 3 plus 2 plus negative 8 plus 5. How much? 2. There we go. Now in both of these cases, you could go further possibly and say that's 1 over 7 to the 8th, because I don't like negative exponents, right? And here I might go further and say what? 4 squared is what? 16? Okay. All right, let's flip. Yes, sir.
Could also the top one be negative 56 if you wanted it, or no?
The top one here?
Yeah.
No, because you're raising it to that power.
Well, I mean, just the number basically, whatever it is, set it to negative 8 and the real number.
Yeah, it would be 1 over that very large number.
Oh, do you 1 over it?
Yeah.
Or is it a negative?
Yeah, whatever that 7 to the 8th is, I'm not sure what it is, but it's a huge number.
Okay.
Okay? All right, on the back, we can also do the same thing with variables. They all have an x. So I have negative 3 plus 2 plus 8. Negative 3 plus 2 plus 8. How much? 7. So that's x to the 7th. It's a positive exponent, so I don't need to go any further. Part B is really 2 problems. Problem 1, Luke, is numbers at the front. Problem 2, Drew, is all the variables at the back. So really the best way to do problem B is to rewrite it and group it. 2 times 5 times 2, where did those come from? What do we call numbers in front of variables? Coefficients. And then x squared, and x to the negative 11. I've found when my students write it that way, they tend to make less mistakes. Group first, then simplify. So someone help me, what's 2 times 5 times 2? 20, thank you, Abby. And let's add these. 2 plus 2 plus negative 11. Is he right? Okay, negative 7. Am I okay with an answer of 20 x to the negative 7? Zach's shaking his head. All right? Let's think about this. Where does the 20 go? On top. Where does the x to the negative 7 go? To the bottom. Why doesn't the 20 go to the bottom? Yeah, the exponent isn't negative. So the tendency there that I want you to watch out for, Hannah, is sometimes people will put both on the bottom. Don't. Just put the exponent part to the bottom. All right. C. And then we're all done. Group your C's. C to the 4th, C to the 3rd, C to the 4th. D to the negative 4th, D to the negative 2. So that's your first step on all of your problems tonight. Group the things that are alike. Noah, can you add up my C's for me? What do I get? All right, C to the 11th. My D's. Tara? Excellent. All right. Am I okay with that answer? Hannah, what do you think? Talk to me. You shook your head no.
Oh, you would do C11 on top.
Good.
D6.
Why would you move the D to the 6 to the bottom? I agree with you.
Because the 6 is negative.
The 6 is negative, and the 11 is positive, so that's an excellent answer. That makes sense. Group, then add. If they're numbers, group, and then what? Did we add these? We multiplied. That's going to be, Luke, your area where people are going to make a mistake. They're going to get confused between the numbers and the exponents. Because when they're exponents, you add them. When they're just numbers out front, you multiply them. So don't get confused by those two. Make sense? Questions?
So when they're like multi-step, like the 20x to the negative 7, then put it on fractions?
Right. If this had been 20x to the positive 7, you'd stop. But since it was a negative 7, it went to the bottom. So I tried to give you a couple different illustrations here of different scenarios of what might happen. And I didn't want to belabor you with 15 or 16 different little examples. All right?